Hello and welcome to Video Stats number 11. We are moving right along in this course. It won't be long. It will be firecracker time, and we certainly want to have everything behind us by then. A couple of things I want to visit with you about today, and the first one is statistically significant, and we're going to focus in on that. Statistically significant, what does it mean? And I know individuals have taken stat courses and they get done with the stat courses and you'd ask them, what is statistically significant? And they did not have a grasp of it. And another thing I want to mention is jargon. We're going to eliminate as much jargon as we possibly can from this course. So today we're going to be looking at statistically significant and jargon. And to start with, we have a normal curve. This is a normal z-score curve. And with this, of course, we have the center here is 0. This is 0 on a normal curve. Then we have 34% here of the population with the first standard deviation below, 34% above, and then we go up here. We have 95%. With the second standard deviation above and below the mean. And then we have about 99% of the population in the third standard deviation below the mean and above the mean. Those aspects here we definitely want to keep in mind. Now, what we're going to be looking at, we're going to be looking at a study this morning, and I'm going to talk to you about a term called alpha. Alpha. You can research this, but I'm going to be looking at that term. Alpha is a standard of rejection that has been set up by the researcher. And you being the researcher, you can set alpha at basically whatever you want to set alpha at. I want you to understand that. Alpha is an arbitrary number that is accepted. But as a researcher, you can set alpha at any level that you want to. For the purpose of the study today, we're going to set alpha at about right in here, at 1.96. Now, where did I get that? And this is a negative 1.96. Or I can set it here and set it here. And it is 1.96. So it is the same. So what this does from here on out, it leaves about 2.5% here, 2.5% here, which indicates that 95 times out of 100, because that's basically what we have between these two lines here, 95% out of 100, 95 times, if you do the study 95 times, it's going to basically turn out the same. Now, what is interesting about this, and I want you to understand that this is an arbitrary term that researchers accept. As a matter of fact, now, with the calculations that we have, we will have a smaller alpha. We can go down to 0.000 or even less alpha. It will be 1,000ths, negative 1,000ths, or a positive 1,000. But you can set alpha at 50 if you would like. Now, if you would set alpha at 50, you would probably be up here in this area here, and you would be in this area here. Now, what 50 would mean is that half of the time you would be right. Now, you can see the difficulty of setting 50%. You probably wouldn't want to read a research article that stated alpha is set at 50, which means that half of the time we are right, half of the time we are wrong. So in this alpha here, we have set it on each tail at 2.5. Now, this is called a two-tailed test here. So we have 2.5% here and 2.5% here. Now, if you have a two-tail test, with alpha 2.5 here and alpha 2.5 here, you can also have a one-tail test. And what a one-tail test is you would put all of alpha, which in this instance would be 5, you would put all of alpha at the positive end or the negative end. So you could put all of alpha here and you wouldn't have any alpha at this end. Or you could put alpha here and you wouldn't have any alpha at this end. So I just want you to understand that. If you do a research project, you basically can set alpha at whatever you want to set it at. The only thing is, if alpha would be 50, which would mean that you would be correct 50% of the time, half of the time, the research probably wouldn't have a whole lot of validity to it. So we set alpha here at these two figures, so we know then that about 95% of the time we are going to get the same result. Now, having said that, what I am looking at is supposedly I would go over to the weight room and there would be 20 of us in the weight room, and someone would come in and they would want to do a study in the weight room. So they did a study, and so 20 would be our population, because we are including everyone, so that's our population. And then after the study was done, it was averaged. And it was found then, since this is a population mean, that the average lifters can lift 200 pounds. Bench press, 200 pounds. This is on an average. But what they've done then, they said, hey Mark, why don't you come over here and bench press? So I come over and bench press, and I bench press a 130. Now, what is our z-score from this? Well, the next thing that we have to do is take the standard deviation, which in this case is 30. And if we work that through, 130 minus 200 is negative 70. You see, when this x is smaller than the population mean, when this score here is smaller than the population mean, we know it is going to be on the left side of our curve. It's going to be a negative number. So if I work this through here, 130 minus 200 divided by our standard deviation, I come up with a number of about 2.3. Now, take your chart, your z-score chart in the back of your text, which they have a z-score chart in the back of your text, and going under z-score, go to 2.3, and you'll see there that at 2.3 we have 0.017, is that correct? Excuse me. 0.0107. Well, this basically, let me scratch this out, got too many zeros in there. So here we have our z-score under z. On the negative side, they have on page 348, they have the negative z-scores, and then they have the positive z-scores. So on the negative z-score, at 2.3, it would be 0.0107. And so that's what it would be here. Now, if I would change this to a percent, I would roughly have 2%. And if I change that to a percentile, then I would have lifted as much or more than 2 people in the room out of the population of 20. Now, I wanted to explain this to you. Now, if and I hope that you see it. Go to your chart, because this is one of the first processes of developing a z-score and developing a process of taking, we've done a little bit before, of taking a raw score and changing it to a Cook score. So I would lift as much as, rounded off, as much or more than 2 people in the room, which means that I would be number 2 on the list. So there would be quite a few ahead of me. And that gives us a picture of what this score is. Now, if we take another score here, let's say that we just change our standard deviation to 4.0, and when I change my standard deviation to 4.0, that gives me a negative 1.75. 1.75. I'll get it here so you can see it. Here we have 1.75. We know that this here is below the mean, so our scores will be below the mean. Then if I look on the z-score at 1.75, I look across there. Under z, there isn't a 1.75. There is a 1.7. So basically what I can do is I can count over to where it says 5th there on the 5th place. And so I intersect 1.75, count over 5 places, and I have 0, 4, 0, 1. Now, basically, what this means then, if I change this to a percent, I have a 4. And what this 4 means then, that I've lifted it as well or better than 4 individuals in the room. Now, I hope that this makes sense to you. You have to go to your Z chart in the back of your book. It's on page 348. I'm going to put that up here. And 349, because you will have some similar operations such as this. The Z is kind of fun to use, and once you get used to it, you can go ahead and use it. I would suggest using this z-score, taking the exact numbers, seeing what you come up with, and then I'm going to have a new set of scores for you. Now then, until video 12, we're going right along. I appreciate what you folks are doing in staff. On video 12, then, we will extend this a little bit to another type of operation. We have Z and T, T as in Terry scores. And they are used just a little bit differently, but they will be introduced. So until we get to video 12, be sure to check your announcements, your chat room, and folks, if you have any forums to complete, please complete them. I appreciate it. I also appreciate all of the good work that you have done in this. So until video 12 then, we'll see you.